Dear colleagues, my name is Fedoseev, and the title of my research is Copyright Protection of FDM Products via Controlled Line Deviations. So in my presentation, I first state the problem, then I tell you a few words about printed document protection technique based on line deviation. And then I show you how to transfer this technique to 3D product protection. Then I discuss copyright information extraction and show you some experimental results. And so, problem statement. Imagine that we have an authorized product or product type, and it can be stolen by some attackers using 3D scanner, then can obtain a 3D model, and then they can print it using their own 3D printer and obtain an illegal copy. How we can protect our product? To answer this question, let us show some previous stages of this scenario. Previously, usually we have a 3D mesh model and slice this 3D model to G-code using any 3D slicer, and then we print it using our 3D printer. And at these stages, we can perform some protection. We can embed a digital watermark into 3D mesh or into G-code. And then when we have an authorized product, we can extract the watermark and compare it with the embedded information. So we can take the information from the product and prove its authorship. And if we analyze an illegal copy, then probably we will not extract the watermark from this illegal copy, because it is hard to capture a good watermark using 3D scanner. So this is an idea, and let me tell a few words how to implement this idea. So we embed our watermark at the slicing stage, and we use a flat product fragment of a small area, and we perform small change in the upper layer of our product, and it is hard to be captured by 3D scanner. The extraction technique must be cheap. That's why we use a mobile camera. And in a good technique, we should be able to automatically extract the watermark from the photo. So the second section is about printed document protection technique, or also known as latent images, which is a prototype of our technique for 3D product protection. So here you can see some examples of printed documents which are visa stickers, drivers and skippers license, passports, and so on. And on this slide, one example is my Spanish visa. You can see that it has a small fragment, less than 1 centimeter in area, filled by two different line structures rotated from each other, and forming the letter E, which means España. And this is an example of a latent image, and now we can describe them as digital watermarks, which are embedded in areas of half-tone features or Guillaume compositions, and they can be considered as texture deviations or texture defects. There are known three basic algorithms for line deviations, which are line angle modulation, dot size modulation, and phase modulation. And now our adaptation of this technique to 3D product protection. In our adaptation, we slice a model into G-code, and in this technique, our watermark is a binary image with large black and white clusters. Then we locate a rectangular area in the upper layer and align it with the watermark image. Then we don't change anything in G-code in black clusters, but we perform any line deviation in white cluster according to three different options. We can rotate lines, we can change line period, or we can shift lines. And finally, we print the modified G-code. So here you can see all the three options visualized by blue and yellow lines and areas. So at the left image you can see line rotation, and the center line period modulation, and at right line shift. It's clear how to produce G-code in left and center image, and here you can see the G-code change when we implement line shift, which is the third option. And now the three products which were captured by our mobile camera, and you see that in the two first methods the line change is visible at this scale, but line shift is not easy to capture by our eyes without any glasses. So now how to automatically extract our watermark to capture copyright information. So line deviation, especially in the case of line shift, is not clearly visible on the product surface, but linear structures are usually good to analyze with Fourier spectrum. And previously, when we studied printed document protection, we developed a spectrum-based technique for printed document watermark extraction. And now we applied it for 3D product photos, and it really works. This is the block diagram of our watermark extraction method. At the first stage, you can see Gabor filter bank construction based on Fourier spectrum analysis. Then we perform filtering using Gabor filters with different parameters, obtaining magnitude and phase information. Then we unwrap phase and perform some final stages. And our approach differs from the traditional one in the following options. The traditional approach uses a predefined filter bank and use magnitude information only, but we use adaptive Gabor filter bank construction and use both magnitude and phase information, and we analyze spectrum and find some peaks from the spectrum and perform narrow band filtering in the neighborhood of these peaks. And finally, let me show some experimental results. First, we tried to extract the watermarks from these three examples of line rotation, line period modulation, and line shift. And at the bottom of this slide, you can see the Gabor filter responses, and it's clear that the area of watermark can be visualized, and it is seen by our eyes. You can see that even the most complex case, line shift, which is at the right, can be revealed by Gabor filter responses. And let me show you some more pictures, more examples of line shift watermark extraction. Here you can see some embedded watermark of different shape and some Gabor filter responses extracted from the printed document from printed product photos. Then these responses were binarized and compared to initially embedded watermarks. And then we calculated two metrics, structured similarity index and a correlation coefficient. And you see that in both two metrics, these images are very close to each other. So our technique can work in the real life. In conclusion, we have successfully transferred the latent image technique to 3D product protection. Watermark in this technique is embedded by G-code modification of the upper layer. 3 different line deviation algorithms have been implemented: line rotation, line period modification, and line shift. Then watermark area is captured by a mobile camera, and watermark extraction is performed by Gabor filtering, tuned by Fourier analysis, and the experiments have shown high quality extraction in terms of structured similarity index and correlation coefficients. So thank you for your attention.